Okay, so today we're just going to do a quick review. We're on 8.2, day 2, and I want to review some of the learning goals for this lesson. So as a review, let's sketch the midpoints of each side of the polygon and what quadrilateral is created by connecting the midpoints. And so I've gone ahead and already made some markers here to help me out, and I'm going to join them ballpark what I think is the midpoints. And if you go ahead and do that on your sheet as well, you'll notice that you do get a parallelogram. That's the shape. When you join the midpoints of each side of a polygon, you end up with a parallelogram. So that side is parallel to that side, and of course this side is parallel to the opposite side. Now the question asks us to label the new quadrilateral accordingly. So if we have A, B, C, D as the original polygon, then we can just continue from there. We can say E, F, let's go this way. Let's go E, F, G, and H. Please remember that vertices are labeled with uppercase letters. Okay, so E, F, G, H is a parallelogram. Learning goals for this lesson are the fact that I can recognize a composite figure. Again, two or more shapes put together. So something like we saw in the last lesson, something like this. But that's not it. That's for sure. Okay, something like that as a composite figure, and it could be just a rectangle and a triangle added together. So that's I think I mentioned a compound word or two figures put together, two words put together type thing. I can determine the total area of a composite figure. So basically, in the shape that I just drew 2 seconds ago, it's something like this. You can calculate the area of the rectangle and the area of the triangle, add them together, and that's how you would determine the total area. I can determine the perimeter of a composite figure. So the only difficulty with this one is you might have to calculate the hypotenuse or one of the legs of the triangle if it's a right triangle and use the Pythagorean theorem, which we've reviewed as well. All right, so those are things to look out for in terms of making sure that you can indeed um, meet each of these learning goals successfully. At the end of the chapter, we will also look at the anticipation guide you completed, and some of these learning goals are in the anticipation guide, and hopefully you can check off yes, yes, yes at the end that you can do each of these. So for all the questions, round your answer to the nearest tenth of a unit when necessary. In fact, this is actually the only question I have for you. So I'm going to leave this question to you to complete as homework for this lesson, and come to class prepared with this. But I'm giving you some hints here. So Brandon works as a carpenter. He's framing a rectangular window that measures 1.5 meters by 1 meter. The frame is 10 centimeters wide and is made up of 4 trapezoids. Find the total area of the frame to the nearest square centimeter. So this is really just two-dimensional. Literally, it's a window and there's a frame around it. That's how I want you to think about it. That's it. Okay? So it's not more complicated than that. Flat 2D shape, think of it that way. But I've gone ahead and labeled this because I think in years past, some students get confused with what the question is giving you in terms of information. So really, I've gone ahead and labeled this for you. You have the height of each trapezoid, or the width of the frame, is 10 centimeters. I've drawn that for you. And what you're looking for is to find out the total area of the frame. So in order to figure out the area of the frame, and just the frame only, because that's what it's asking you for, the total area of the frame, that's just going to be the portion. That's just going to be the portion that is obviously around. Okay, so that's the portion. That's the area that you're looking for. If that's the case, then the portion that you're not going to include is this interior portion here. You're going to figure out a way to be able to solely calculate the frame. Okay, so I've given you some hints in this diagram. Go ahead and copy what I've done and see if you can get your math juices flowing and figure out what the total area of that frame is. And we'll see you in class.